So welcome back to KSET 2017 paper. We'll discuss here questions and solutions. See, the absolute value of the integration r cross dr around an equilateral triangle of side A with origin at its center is. So this is the question given, integration of r cross dr. Integration of r cross dr gives area of a given system. So here the system is equatorial triangle. That means all the three sides are equal. A. We know that area of equilateral triangle is half into base into height. Okay, so which is equal to half into base is A, and what is height? Height we have to calculate. Okay, if suppose this is 90 degree and each side of a equatorial triangle is 60 degree, angle is 60 degree, we have to calculate height. How to calculate this height? We know that sine 60 degree here is equal to opposite by hypotenuse. Hypotenuse is A, so opposite side is this one. So therefore opposite side is equal to A into sine 60 is root 3 by 2. So therefore, this is height H. So this is H. Opposite side is nothing but H. So height is equal to A root 3 by 2. So A into root 3 by 2. So therefore overall answer is root 3 A square by 2 to the 4. So root 3 A square by 4, but this is the answer given. Answer is root 3 A square by 4. Maybe this question gets a grace marks. Okay, so there is no any options. If it is 4, so then this is the correct answer. And this is the question number 2, which based on Fourier transformation. This is the question given. We have to calculate f square of f of x, where f into f of x is equal to 1 by root 2 pi integration of minus infinity to plus infinity f of x e power minus I kx into dx. So this is Fourier transformation of f of x. We have to calculate f square of f of x. But you should remember that f of s, which is equal to f of x, okay, into 1 by root 2 pi integration minus infinity to plus infinity f of x e power minus I kx dx. Okay, and f inverse of f of s is equal to f of x, if this is f of x, f into f of x, and this is f of s, and f of s is equal to 1 by root 2 pi into f of s into e power plus I kx into ds. Okay, because of f of s. This is Fourier transformation of f of x, which is equal to f of s is equal to 1 by root 2 pi into minus infinity plus infinity f of s ds. In place of x, I am writing s and ds. Okay, next, then Fourier transformation of f of s is equal to f of x, which is equal to 1 by root 2 pi integration of minus infinity to plus infinity, sorry, this is minus infinity to plus infinity. So then f of x e power plus ikx into dx. F of x 1 by root 2 pi f of x e power ikx dx. So sorry, again I made a mistake. F into f of x is equal to f of s, correct, 1 by root 2 pi. So this is f of x into e power minus ikx into dx. This is correct only. And f inverse of f of s, see. Okay, this is over. Next, f inverse of f of s is nothing but f of x, which is equal to 1 by root 2 pi into integration minus infinity to plus infinity and f of s e power ik's ds. Okay, so e power ikx and ds. Okay, next, so this is f inverse of f of s. Next, like that, f inverse of f of x, you have to calculate. See, f inverse of, okay, first I am going to calculate f square of f of x, because that only we are going to calculate. So that can be written as f into f of x, right? So then f into f of x means f of x means 1 by root 2 pi integration minus infinity to plus infinity f of x e power minus ikx dx. Okay, and we know that from this expression then f inverse of f of x can be written as 1 by root 2 pi integration minus infinity to plus infinity f of x e power ikx dx. Okay, but here we have minus ikx, so here extra term minus, so therefore we can write this as f into, so this is f inverse of f of minus x, because f inverse of f of x is plus ikx has to come, but here minus ikx is there. So therefore this is f of minus x, therefore f inverse and f cancel, so answer is f of minus x. So the Fourier transformation of df by dx is related to the Fourier transformation hk is equal to minus infinity to plus infinity e power minus ikx f of x dx of the function f of x. So that is f of x by, these are the given options. So we have to calculate Fourier transformation of df by dx. So this we have to calculate. We know that Fourier transformation of d power n f by dx power n, which is equal to minus ik whole power n into hk. Okay. Yes. Next, therefore, here you have to calculate df by dx. df by means n power is 1. So therefore, f of df by dx is equal to minus ik power 1 into h of k. So which is equal to minus ik into hk. So option C is correct answer. This is the question which from complex integration. The value of the integral z square dz where C is a unit circle is. So this is the question given. We know that z is equal to r into e power I theta. For a unit circle, that means r is equal to 1. So then z is equal to e power I theta. Then dz is equal to e power I theta into I, coefficient I into d theta. Therefore, that equation becomes integration, and a circle is a unit circle, and we know that circle, the circumference of the circle is, or the circle varies from the limit 0 to 2 pi, 360 degree, 0 to 360 degree. If I start from here, if you want to complete one circle, it takes 360 degree. So it varies from 0 to 2 pi, and z square means if this is z and z square is e power 2 I theta. So e power 2 I theta, and dz is I into e power I theta into d theta. Okay, so which is equal to integration 0 to 2 pi I into e power 2 I theta and I theta e power 3 I theta into d theta, and which is equal to I into e power 3 I theta. So if we integrate this, we will get e power 3 I theta divided by 3I, limit varies from 0 to 2 pi, and I gets cancelled. Okay, next if you substitute this, so which is equal to e power 3I pi 2 pi, that means 6I pi minus e power 0 divided by 3. But we know that e power any even pi is 1 minus e power 0 is 1 divided by 3. 1 minus 1 is 0. Okay, e power 6 I pi. So e power exponential power of any even pi is 0. Sorry, 1, and e power 0 is 1, and exponential power of any odd pi is minus 1. So answer is 0. B is the correct answer. So this is the question given. The value of the integral 1 by pi I integration c dz divided by z square minus 1, where the counter C is a circle of radius A is not equal to 1 with origin as its center, is given by these are the options. We know that integration of f of z dz is equal to 2 pi I into sum of residues. Okay, and what is this residues? Residue is equal to 1 by n minus 1 factorial into limit z tends to a d power n minus 1 divided by dx power n minus 1 into z minus a into f of z. Okay, so z minus a whole power n into f of z. So this is the formula to calculate residue. Next, let's see. The question is integration of 1 by pi I into 1 divided by z square minus 1 into dz. I think this is the question. Yes. So we can write this as dz, which is also equal to 1 by pi I integration of dz divided by z plus 1 into z minus 1. That means you can write this as z square minus 1 square. So a square minus b square can be written as a plus b into a minus b. So that is z is equal to z square is equal to 1 is nothing but z is equal to plus or minus 1. This is for z is equal to minus 1, for this z is equal to minus 1. So now we have to calculate this f of z dz is equal to 2 pi into sum of residue. So how to calculate residue? Residue is equal to limit. Okay, first let us take, so this is z plus 1 power is 1. So z plus 1 whole power 1. So z minus 1 whole power 1. So it's a pole of order 1. So we can write this as 1. 1 minus 1 is 0. So it's a 0 factorial. Okay. Next, limit. First I am going to take for z tends to a plus 1 and minus 1. Okay. So z is equal to plus or minus 1 is there. So for z is equal to plus 1 d power 0, because 1 minus 1 is 0, n is equal to 1. How to choose? Because power is 1 here. Okay. So z tends to plus 1 d power z minus 1 z plus 1 into z minus a into f of z. So 1 divided by z plus 1 into z minus 1, and another one is plus limit z tends to minus 1. So this, for this z plus a into 1 divided by z plus 1. So this is z plus 1 into z minus 1. Okay. For z plus 1, in the numerator we have to write z minus 1. For z minus 1 in the numerator we have to write z plus 1, because if I substitute 1 here, it will become 0. Okay. So that's why into, see, z minus 1 cancel, 1 divided by limit z tends to plus 1 into 1 by z plus 1 plus limit z tends to minus 1 z plus 1 and z plus 1 cancel, 1 divided by z minus 1. Okay. So which is equal to z tends to plus 1. So 1 plus 1 2, 1 by 2 plus 1 by, here z is equal to minus 1. So minus 1 divided by minus 2. So answer is 0, because 1 plus 2 minus 1 minus 2, 1 by 2. So answer is 0. So in the options, so we have seen that, so what are the given options? Option number D is correct. 0 is independent of A, because so 0 is there in the option number D. So answer is 0, and it's also independent of A, because whatever the value you have chosen here, A, for example, if it is z is equal to 2, again you will get here z plus 2, z minus 2. Okay. You have to substitute 2 and 2, answer again same. So whatever may be the 3, 4, 5, so whatever the value the A as, it independent of A. Okay. So this is the question given. Consider the matrix A is equal to 1, 1, 3, 5, 2, 6, minus 2, minus 1, minus 3. The product of the eigenvalues of the matrix is to calculate. See, we know that the determinant, if we multiply the given eigenvalues, it has to give the determinant of the given matrix. So, see, the eigenvalues. Okay, first I have to calculate determinant of A, which is equal to 1 into minus 6 plus 6 minus 1 into 5 3 is a 15 minus 6 2 is a 5 2 is a 10, 5 3 is a 15 and 6 2 is a 12. So plus 12 and plus 3 into minus 5 and plus 4. So answer is 0 minus 15 plus 12, 3. Okay, so minus into minus plus 3. Next here minus 5 plus 1, so minus 1, so plus 3 into minus 1. So answer is 3 minus 3 is equal to 0. So determinant is 0. We know that the properties of eigenvalues, the product of the eigenvalues gives determinant of matrix A. Whatever the matrix, the eigenvalues you are calculating the matrix, so that eigenvalue, if you multiply the eigenvalues, that is also equal to determinant of that matrix. So answer is 0. Option number B is correct. So the average value of a function f of x is equal to sin x in the interval 0 to pi is, so these are the options given. The average value of sin x is integration of sin x dx divided by integration of dx. Limit varies from 0 to pi, which is equal to integration of sin x is minus cos x. Limit varies from 0 to pi divided by dx is pi. Dx is x and limit is pi to 0. I can write that as a pi, which is equal to minus of cos pi minus cos 0 divided by pi, which is equal to minus of cos pi is minus 1 minus cos 0 is 1 divided by pi. So minus 2 minus into minus plus 2 by pi. So 2 by pi is the correct answer. So the eigenvalues of a real 3 cross 3 matrix must have at least one of the eigenvalues real, must be all real, must have at least 2 real eigenvalues, must have all the 3 eigenvalues imaginary. This may be wrong. So sometimes may get imaginary eigenvalues of real 3 cross 3 matrices. So quite difficult, but at least one of the eigenvalue must be real. You can choose at least one of the eigenvalue must be real. It's a safer zone. So these also we can't say and must be all, but must have at least one of the eigenvalues is real. So option A is correct. So this is also a problem related to matrix. So here, see, a 3 cross 3 matrix has eigenvalues 0, comma 2 plus I, 2 minus I. Which of the following statement is correct? So the matrix is Hermitian, the matrix is unitary, the matrix is singular, the matrix is non-singular. So 0, 2 plus I, 2 minus I. So in the eigenvalues imaginary terms is there. See, these are all imaginary terms. So we know that for a Hermitian eigenvalues, for a Hermitian matrix, eigenvalues are real. So option A is not correct. And the matrix is unitary. If you want to say the matrix is unitary, at least one of the eigenvalues is plus 1 and minus 1. So this is also not correct answer. Plus 1 minus 1 must be there for a unitary matrix. And the matrix is singular and the matrix is non-singular. For a non-singular matrix, there is no 0 terms. 0 terms will not become as a eigenvalue. But here 0 is there. So this is not a correct answer. So option number C is correct. The matrix is singular. Okay.